Alright, so let's still see the expansion of sets type 2. Expansion of the form a plus b times c plus d. That's multiplication of two binomials, and we have this. So we'll be using the same idea. So let's start with examples. Example 1. Simplify. Square root of 6 minus square root of 2 times square root of 6 plus 3 square root of 2. So this is what we have. Alright, so solution. Square root of 6 minus root 2 times that. The same thing, square root of 6 will come out. Then we give what? Square root of 6 plus 3 square root of 2. Then minus square root of 2 will come out. We give square root of 6 plus 3 square root of 2. Now, square root of 6 times square root of 6. So let's expand square root of 6 times square root of 6. And plus square root of 6 times 3 square root of 2. Let me blend the line. Then here, let's see, minus square root of 2 times square root of 6. Negative times positive is negative. So square root of 2 times that, square root of 2 times 3 square root of 2. So this is what you have. Square root of 6 times square root of 6 is just 6. Plus, now this 3 will multiply 1 here, so you have 3 times 6 times 2 is square root of 12. Minus 2 times 6 is 12. Minus 3 will multiply 1, so 3 times square root of 2 times square root of 2 is just 2. So we have 6 plus 3. We can reduce this. It is 4 times 3. Minus here 2, the same thing, which is 4 times 3. Minus 3, 2 is 6. So we have 6 plus 3 times square root of 4 is just 2. Then we still have our square root of 3. Minus square root of 4 is 2. We still have square root of 3. Minus 6. 3, 2 is 6 square root of 3 plus 6. Then minus 2 square root of 3 minus 6. So this is what we have. They are like terms. And this one too are like terms. This one is positive 6. This one is negative 6. So they cancel out. We get 0. Now here will be 6 minus 2, then square root of 3. 6 minus 2 is 4, square root of 3. This is what we have. 4 square root of 3. Let's see the next example. Alright, so we resume to this one. Simplify 1 minus square root of 3 times 1 over 3 plus square root of 3, giving your answer in the form p plus q square root of 3. So solution here. Now, the same thing, 1 will come outside, we give what? 1 over 3 plus square root of 3. Then minus square root of 3 will come out, we give what? 1 over 3 plus square root of 3. Now, 1 times 1 over 3 plus 1 times square root of 3. Then here minus square root of 3 times that, times 1 over 3. Negative times positive is negative. Always mind you, be very careful with that. Square root of 3 times square root of 3. 1 times 1 over 3 is 1 over 3. Plus here we get square root of 3 minus square root of 3 times 1 over 3. Don't forget, 1 over 3 is not inside square root. So 1 over 3 will multiply 1. So you get 1 over 3 is square root of 3. Minus square root of 3 times square root of 3 is just 3. Like terms, 1 over 3 minus 3. They are like terms. So 1 over 3 minus 3. Then plus square root of 3 minus 1 over 3 square root of 3. Now 1 over 3 minus 3. This one is over 1. LCM 3. 3 will go into 3, 1. 1 times 1, 1. Minus 1 will go into 3, 3. 3 times 3, 9. Plus, check here. The coefficient here is 1. This one is negative 1 over 3. So it is 1 minus 1 over 3. Then square root of 3. Here we get negative 8 over 3. Plus, this one is over 1. Right? So 1 minus 1 over 3 is just straightforward 2 over 3 square root of what? 3. Now check something here. You see they have the same denominators. So this one can also be written as, so, or you can also write it as over 3. Negative 8 plus what? Plus 2 square root of what? 3. So you can also write it as that. So negative 8 plus what? 2 square root of 3 all over 3, or better still, you can write it like this. But the question says we should leave our answer in the form p plus q square root of 3. So there is no way we have to write it like this because they said we should leave our answer in this form. So in that form, that's p plus q square root of what? 3. So we can say that p is what? Negative 8 over 3. Then q is what? That's 2 over 3. So p is negative 8 over 3. Then q is what? 2 over 3. Very, very simple. If you don't understand, play back the video for better understanding. Let's see question 3, the next example. Let's see this one. Simplify 6 plus 2 square root of 5 times 3 minus 2 square root of 5. Alright, so 6 out. Then we give what? 3 minus 2 over square root of 5. Then plus 2 square root of 5 out. Then 3 minus 2 over square root of 5. Now we get 6 times 3 minus 6 times 2 over square root of 5. Then plus 2 square root of 5 times 3. Then here, positive times negative is still negative. So 2 square root of 5 times 2 over square root of 5. Now 6 3 is 18 minus, this one is out of 1. 6 will multiply 2 so that we get 12 over square root of what? 5 plus, we'll have 2 times 3 is 6. So you get 6 square root of 5 minus square root of 5 will cancel square root of 5. Now 2 times 2 is 4. It's 4. Now 18 minus 4. 18 minus 4. Then let's see, minus 12 over square root of 5 plus 6 square root of 5. Now we'll be doing something we call rationalizing the denominator of a set. A set is an irrational number. So when we rationalize an irrational number, we get a rational number. Take note of that. When you rationalize an irrational number, it tends to become what? A rational number. So we'll be rationalizing the denominator of this set, which is an irrational number. Now, we'll be doing that, but let's start here because okay? So if you want to rationalize the denominator of this set, what do we see here? The denominator, what do we see? We see square root of 5. You use this square root of 5 to multiply 12. Then use it to multiply square root of 5 again. So use it to multiply 12 and square root of 5. 8 minus 18 minus 4, we obtain that is 15. No. That's 14. So that's what I'm trying to say. 12 over square root of 5 times square root of 5 all over square root of 5. We haven't done anything, right? Because when you cancel it, you still get that. We want to take the irrational